Hello, everyone. First of all, I'd like to say a massive thank you to everyone who's watched my first video on the multiply process and given me really good feedback, some of which is really encouraging. So thank you so much. Today, I am going to go over another concept, and that is the Gini coefficient, which surfaces across all of the syllabuses listed here on this slide. So welcome back to Economics with Mr. Cole. Well, in terms of definition, the Gini coefficient is the area between the Lorenz curve and the 45-degree line divided by the total area under the 45-degree line. It ranges from 0, which indicates perfect equality, to 1, a situation of perfect inequality. So I'm just going to go over two examples, two countries. The first one is Brazil in 2015. And as you can see, we have 5 quintiles here. So quintiles means 20%. So in order to read this pie chart, you would first need to look at the first quintile of the population. That means the lowest 20% of the population actually have 3% of the total labor income, right? And that means if we move on to the next quintile, the second quintile, right? The next quintile possesses 8% of total income. And then the third quintile, so again, the next 20% of the population has 13% of total income, and so on and so forth, right? And another country, El Salvador, in 2015 as well, so same year for both countries. And again, in this case, also look first at the lowest 20%, the first quintile of the population that has 5% of El Salvador's total labor income, which is, in terms of percentage-wise, 2 percentage points higher than Brazil's first quintile, because that was 3% for Brazil, wasn't it? Right? And then in El Salvador, the next quintile, so the second quintile, possesses 10% of the total income of the country, and so on and so forth. Right? So, question. Using the given information in the previous slides, sketch and label a Lorenz curve for Brazil and El Salvador in the following box. And you would notice that the 45-degree line that I've drawn here is actually the line of complete equality. All right, so first of all, we would need to label the axis, the y-axis and the x-axis. So for the y-axis, we have got cumulative income, percent, and the x-axis, we've got cumulative population, which is again percent in terms of its units. And of course, we've got the actual percentages labeled along both axes. So for Brazil, I've basically, gotten all of the information in the pie chart and written it down here. So we're going to first indicate on the box, okay, the following information using crosses, right? So the bottom 20% of Brazil have got 3% of total labor income. So that means it's, as you can see, the first cross that I've drawn here actually demonstrates it. And then the second 20% of the population, so the next quintile, right, has 8% of total income. And that needs to be added together with the 3% earlier to make 11%. So that means the first 40, okay, first quintile plus second quintile of the population possesses 11% of total income. And you can see my second cross as indicated on the box. And as for the third quintile, it has 13%, but remember we need to add the previous figures from the first two quintiles as well. So we've got 3 plus 8 plus 13, that's 24%. That means the first 60% or the first 3 quintiles of the population possesses 24% of total income in Brazil. Okay, and you do the same for the fourth quintile. And then you've got 4 crosses already. And then of course the fifth one is going to be right at the top. So at the top right-hand corner, because I mean it's everybody in Brazil, right? So the entire population. So as you can see, we would be able to draw the Lorenz curve for Brazil using, well, it's a sketch. It's not going to be 100% accurate, but it's going to look something like that, right? And we're interested to find out the Gini coefficient. So that means we'll take area A divided by areas A plus B. And in this case, you would have 0.52. Yeah, and I've got the figures from the World Bank. So, that's for Brazil. So I'm just going to label it as Brazil 2015 because I'm going to do the same for the second country, El Salvador. And again, I've plucked out the information of the 5 quintiles in textual form from the pie chart earlier. I'm just going to do the same method as I did for Brazil, right? So the bottom 20% in El Salvador earned 5% of total income in the country. So that's going to be just slightly higher. Remember for Brazil, it was 3%, right? But for El Salvador here, it's 5%. So the cross is going to be just a tad bit higher than before, than for Brazil. And then second 20% possesses 10% of total income in El Salvador. That means the first 40% of the population, the first quintile plus the second quintile, has 15% of total income, right? So remember, it's cumulative, as you can see in the axis labels as well. And then we move on to the third 20%, right? So clearly much higher in terms of, the accumulated income for the first 60% of the population. For El Salvador, that is 30%. As compared to Brazil, I think that was 24%, if I'm not wrong, earlier. Right, and just do the same for the rest of the data points. And again, the fifth and final cross for the country will be at the top right-hand corner. So we're just going to draw, or rather sketch, the Lorenz curve for El Salvador. And you can see that El Salvador's Lorenz curve is closer to the line of complete equality. All right, as you can see, the 45-degree line, as I've mentioned earlier, indicates the line of perfect equality. And for El Salvador in 2015, in the same year, its Lorenz curve is closer to the line of complete equality, which means, generally speaking, El Salvador has a more equal income distribution compared to Brazil in 2015. All right, so I'm just going to remove the curve that I sketched for Brazil, and then again show how the Gini coefficient is calculated, right? So area C divided by area C plus D, that's for El Salvador, and you get a Gini coefficient of 0.41. Again, I got this data from the World Bank. So, Lorenz curves are helpful in showing the income distribution, how income inequality differs across countries. And actually, you can also do an intertemporal comparison. So for example, you might not want to do a cross-country comparison or interspatial comparison across space, that is, between two countries. You could, for example, have Brazil 2015 and Brazil 2018 and see how income inequality has changed over time in Brazil. All right. If you want to do an intertemporal comparison within a country. So just to recap on the figures, and looking at the diagram, you can see that even without getting those figures from the World Bank, you could immediately tell that Brazil had a higher Gini coefficient than El Salvador in 2015. And that's basically the end of the content that I wanted to go over in this video. So I just want to make a quick note on the requirements across syllabuses. So depending on what exam board and syllabus code you're taking, there are slight differences. So for example, in higher level IB, you need to know how to construct the Lorenz curve from income quintile data. So exactly what we did earlier. All right. Here's some follow-up questions for you to think through. And again, not all of them will be relevant depending on your exam board and syllabus code. But, you know, just always good to exercise your mental faculties anyway. Right, first, define the term poverty trap. And then second, explain different reasons for which a highly unequal income distribution could impede economic development. Third, explain why economists use the Gini coefficient in measuring the standard of living of country. And finally, discuss policies available to the government to reduce income inequality. Definitely ponder over these questions because they might be helpful. They should be quite helpful in your learning. And again, in terms of tutoring, I do tutoring via Zoom and in person as well for these syllabus codes for both A levels and the IB. And again, my profile is shown here. And if you've got any questions, please don't hesitate to reach out to me at my email address. Thank you very much. Goodbye.